Dear children, today we will start another chapter of physics, that is magnetic effect of electric current. And in this chapter we will discuss about Oersted's experiment. Then we will discuss basic properties of magnets. Afterwards we will discuss what is meant by magnetic field, then magnetic field lines and properties of magnetic field lines. Okay, these things we will discuss in detail in this session. Okay, so first of all we will discuss about Oersted's experiment. So Oersted was one among the great scientists who noticed that whenever current is flowing through a wire, a magnetic field is produced. So what was his experiment, that we will see. So the pictorial representation of that experiment is shown here. You can see that a battery is there. It is connected through a key to a wire. Okay, is it clear? So south north like that it is shown, no? So a wire is there. That wire is connected through a switch to a battery. And now the current is flowing from, in first diagram you can see that current is flowing from south to north. So that time what happens is that this current carrying wire is producing a magnetic field. And how to know that whether a magnetic field is there or not? With the help of a compass needle, no? So when a magnetic compass needle, below you can see that below that wire, a magnetic compass needle, when it was kept, it was deflected in a particular direction. That already it is shown, you can see here. Okay, it was deflected towards west. Understood? Is it clear? So here in this case, when current was flowing from south to north through the wire, so the magnetic field is produced by the wire, and because of that wire, when a compass needle was kept below the wire, that is getting deflected towards west. Now in the second diagram you can see this, that the direction of the current is reversed. How to reverse the direction of current? By reversing the positive and negative terminal of the battery, no? By reversing that you can reverse the direction of current. So in that case what happened is that when the needle was kept, he could notice is that the deflection of the compass needle towards east, which means the direction of current affects the direction of magnetic field. No. In first case, magnetic field the magnetic field produced by the current carrying wire deflect the compass needle towards west, and in second case it deflects the compass needle towards east. So from these two experiments he concluded that whenever current is flowing through a wire, a magnetic field is produced, and this magnetic field depends on the direction of the magnetic field depends on the direction of current, and the strength of the magnetic field depends on the strength of the current. This was his conclusion. Okay, is it clear? Now we will discuss about the basic properties of magnets. So which are the basic properties of magnets? That already you have studied in smaller classes. First one is attractive property. So what is meant by attractive property? These magnets can attract magnetic substances, which means iron, nickel, cobalt, those materials can be attracted by magnets. That is known as attractive property. Okay. And next one is directive property. Directive property means whenever you are aligning, if you are suspending a magnet in air, that magnet will align in geographic north-south direction always. That you might have noticed also, no? If you are suspending a magnet with the help of a wire, you can see that this magnet will align in geographic north-south direction, and that property is known as directive property. And next one is like poles repel and unlike poles attract. No need to say, no? You know that magnet has two poles, one north pole and south pole, and north pole will repel, north pole and south pole will attract, and south pole will repel. That's why like poles repel and unlike poles attract. Okay. And next one, magnetic poles always exist in pairs. In the case of electric charge, one positive charge alone or one negative charge alone can exist. But in the case of magnetic poles, that is not possible. we cannot isolate a single north pole or a single south pole. Always these poles will exist in pairs. That is the main difference between electricity and magnetism. In the case of electrostatics, we can say that isolated charges will exist. One single positive charge or one single negative charge will exist. But in the case of magnetism, a single monopoles will not exist. Monopoles will not exist means we cannot isolate a single north pole or a single south pole. You may think that if by taking a magnet, if you are cutting it vertically, you can get a pole. It is not possible. When you are cutting the magnet vertically also, you will get a magnet with a lesser strength, that much only. Okay, so we cannot isolate a pole. Is it clear? And now we will discuss what is meant by magnetic field. So the magnetic field means it is the region around a magnet within which its influence can be experienced. When you are keeping a magnet in a region, so with the introduction of that magnet, it can influence, it can attract some magnetic substances. So up to which space or which region it can attract that magnetic substances, that region is known as magnetic field. Okay, so magnetic field means the region around a magnet where its influence can be experienced. That is known as magnetic field. Okay, is it clear? Now we will discuss about magnetic field lines. So this concept of magnetic field lines was introduced by Michael Faraday to visualize magnetic field. Okay, to visualize magnetic field, Michael Faraday was the first person who introduced the concept of magnetic field lines. Actually, no such field lines are existing. They are imaginary lines. If you are keeping a magnet and if you are looking there, you cannot see any field lines. They are imaginary lines. To visualize the concept of magnetic field, this concept or this term was introduced by Michael Faraday. Okay, so what is meant by magnetic field lines? First of all, we will see the definition. It may be defined as the curve, the tangent to which at any point gives the direction of the magnetic field at that point. So it is defined as a curve. It is a curve. And what's the specialty of that curve? At each and every point to that curve, you can draw a tangent. So that tangent will give the direction of the magnetic field. Okay. It is a curve, and at each and every point when you are drawing a tangent to that curve, that direction, that tangent gives the direction of the magnetic field. Okay. So it is a curve, the tangent to which at any point gives the direction of magnetic field. Okay, is it clear? Or one more definition is there. We can define in this way also. The path along which a unit north pole would tend to move if free to do so. I told you already, we cannot isolate a unit north pole, but for the definition sake we are saying like that. If we are keeping a unit north pole, okay, and in which direction that or in which path that unit north pole will take if it is in a magnetic field, that path is the magnetic field lines. Okay, is it clear? So either of the definition you can study, whichever is convenient to you, you can study. Understood? No? And now we will discuss about the properties of, before discussing properties of magnetic field lines, we will see what is the shape of the magnetic field lines of a bar magnet. So the magnetic field lines of a bar magnet will look like this. So you can see here north pole on the right side and south pole on the left side. So here you can see that these field lines will be looking like this for a bar magnet. Okay. So from this we can say that, which some properties we can say that. Which are the properties? It starts from north pole and ends at south pole outside. No? It is starting from north pole, you can see that arrows, and ending at south pole outside, and inside it is from south to north. Is it clear? So at each and every point you can see here we can draw tangent. Okay, here at each and every point if you draw the tangent, that tangent shows the direction of the magnetic field at that point. Is it clear? Okay. So this is about the magnetic field lines of a bar magnet. It is very much important. Normally it is asked to draw the diagram. Okay. Now we will discuss properties of field lines. So first property, already we discussed. They are closed curves which start in air from the North Pole and ends at the South Pole and then return to the North Pole through the interior of the magnet. Okay, so it starts from North Pole. Outside the magnet it is from North Pole and ends at the South Pole, and inside it is from South to North. Okay, is it clear? Or we can say that they form closed loops. They form, magnetic field lines form closed loop because outside it is from north to south and inside it is from south to north, which means they form closed loops. Okay. And next property, that tangent gives the direction of magnetic field. That already it is there in the definition of field lines itself. That is, at each and every point, by drawing the tangent to the curve gives the direction of the magnetic field. Okay. And next property is that two field lines will not intersect. Two magnetic field lines will not meet. So what is meant by they will not meet? So here in previous case itself you can see that. Here itself you can see that whether the field lines are meeting. You can see many field lines, you can see that the field lines are not at all meeting. Why they are not? If they are meeting, what happens? If the field lines will meet, at the meeting point we can draw two tangents, which means it shows two direction of magnetic field. That is not possible because at each and every point only one direction of magnetic field will be there. So if the field lines are intersecting, there will be two tangents can be drawn to that point, which means two directions will be there. Directions will be there for magnetic field, and that is contradictory. So it is not possible for field lines to intersect. Okay, is it clear? And next property what it is? The relative closeness of the field lines gives a measure of the strength of the magnetic field. The relative closeness of the field lines gives a measure of the strength of the magnetic field, which means if the field lines are closer, magnetic field strength in that region will be more, and if the field lines are much separated in that region, magnetic field will be weak. So that also you can see here, where you can see here in this diagram itself, near to the poles here. At these points, near to the poles, you can see that more field lines are there. If you consider a small area, there more field lines will be there, which means at this region, strength of the magnetic field will be more. Okay, so wherever more field lines are there, so here and here the magnetic field strength will be more in comparison with this region and this region, because in those regions magnetic field lines are much separated. So wherever magnetic field lines are closer, that region shows the more strength magnetic field. Okay, is it clear? And last property is that in a uniform magnetic field, the field lines will be parallel. If it is a uniform magnetic field, so in that uniform magnetic field, we can see that field lines will be parallel. Okay, parallel field line shows that it is a uniform magnetic field. So these are the properties of field lines. So first property is that start from North Pole and ends at South Pole, and inside it is from south to north, or we can say that they form closed loops. Second property, tangent gives the direction of magnetic field. Third property, two field lines will not intersect. And fourth property, the strength of the magnetic field is indicated by the closeness of field lines. And last one, the uniform magnetic field, the field lines will be parallel. Okay, is it clear? So you can refer these things, and if you are having doubt, you can contact me. Thank you.